Hello students, welcome to MEMONEET. This is Ravikant, your physics teacher, and I hope you all are doing very well and you did well in your all BPTs from BPT 1 to BPT 8 and you scored well and you learned a lot from it and had a good practice of the numericals and the syllabus, revision of the syllabus, right? Now in BPT 9, upcoming is BPT 9, and in BPT 9 you have your cumulative test in which all the topics or all the subjects, all the chapters which you had in from BPT 1 to BPT 8 will be covered in it. And this now the upcoming videos which we are going to make is for the revision of these chapters. And in these videos, we will be simply discussing few numericals out of these chapters so that you have a quick revision of the concepts of the some important topics out of these chapters, right? So in this video today, I'm going to take for unit and dimensions and current electricity, right? So in unit and dimension, the thing which we are going to discuss with our first numerical is in for the significant figures, right? And the first numerical says that 5.74 gram of a substance occupies 1.2 centimeter cube, right? So they have given mass to us and they have given volume to us. They are asking us to express its density keeping significant figures in view. Keeping significant figures in view means now we have to write our answer in the correct number of significant figures. Now for to solve this question, we should have a proper view of the rules for the significant figures to when some operation is being done and then the result is to be written in the some number of significant figures. So the operation which we are supposed to do here is the division, because what they have given is mass and volume and they are asking us density. So mass has been given to us as 5.74 gram and volume has been given to us as 1.2 centimeter cube. So from here we can say density is equals to mass upon volume. So mass is 5.74 upon volume is 1.2. This was result in 4.783 gram per centimeter cube, right? So now we have our answer is 4.783, right? Now here the mass has three significant figures. Mass has significant figures is equals to 3 and the volume has significant figures is equals to 2. So when multiplication or division has been done, the answer is always written in least number of significant figures. So the least number of significant figures here is 2. So our answer should also be in least number of significant figures. So it should be in two significant figures. So to take two significant figures, this is to be taken and this part is to be removed. Now we see that this part is this 8 is greater than 5, so this 7 will increase by 1. So we'll have our density is equals to 4.8 gram per centimeter cube, right? Density will be equals to 4.8 gram per centimeter cube as per the significant figures, right? So the rule which we have applied over is that whenever two quantities or two or more quantities are multiplied or divided, then the answer is written in the number of least number of significant figures of the quantities which are being multiplied or divided, right? So here 5.74 and 1.2 are being divided. So 1.2 has the least number of significant figures, that is 2. So we will write our answer in two significant figures. So our answer will be equals to 4.8 gram per centimeter cube, right? So this was for significant figures. Let's see another numerical. The other numerical is related to dimension analysis and it says that the force F is given by expression F is equals to A cos Bx plus C sin dt, where X is the displacement and T is the time. Then the dimension of D by B are same as those of the options are being given to us. Alright. So here if you see that B is an argument of cos and it has been written multiplied with x, and D is when multiplied with t becomes an argument of sine. So cos and sine has an argument as angle and angle is dimensionless. Means dimension of B is equals to dimension of x inverse. Then only B into x will become dimensionless. Similarly, your dimension of B will be equals to inverse of dimension of t. So from here we can say that dimension of B is equals to L minus 1 because L is displacement, X is displacement, and dimension of D will be equals to T minus 1 that because t is what? T is your time as given in the question. So they are asking us the dimension of d upon dimension of b, right? So dimension of d is t inverse and dimension of b is L inverse, and this would result in L p minus 1, and this is the dimension of velocity. So out of this we have the first option itself as velocity. So the correct answer here will be velocity. So what we have seen here is that sine, cos and the trigonometric functions take the input, that is the argument, as a dimensionless quantity which is an angle. So this bx and dt are dimensionless, right? Because they are dimensionless, then therefore then b will have a dimension inverse of x and d will have a dimension inverse of t. Using this information, we get the dimension of d upon dimension of b is equals to L t minus 1, right? This was the thing. Now let's get into the third numerical. The third numerical says that it is related to your error analysis. So it says that in an experiment, four quantities A, B, C, and D are measured with percentage error 1%, 2%, 3%, and 4% respectively. Then the quantity P is calculated as follows. Percentage error in P is. So if quantity P is being calculated as follows, so we have to calculate percentage error in P, and in case of percentage error, when the quantities are being multiplied or divided, and or if it's a case of quotient as it is here, then the percentage error is the sum of the absolute error, percentage error of each, right? Like that is what I want to say is that percentage error in P will be equals to 3 times the percentage error in A plus 2 times the percentage error in B plus percentage error in C plus percentage error in D, right? This is how we calculate the percentage error. So the percentage error in P will be equals to 3 into percentage error in A is 1 plus 2 into percentage error in B is 2 plus C, that is percentage error in C is 3 plus percentage error in D, that is 4, right? So it will be equals to 3 plus 4 plus 3 plus 4, and this is equals to how much? Is equals to 14%. So the correct answer will be 14%. So here the correct answer is 14%. That is, if the percentage error in A, B and A, B, C and D are 1, 2, 3, 4 respectively, and P is being given by this formula, then the percentage error in P will be equals to 14%, right? So here what we have used, here we have used the combination of the concept of combination of errors, in which the quantities which are being combined over here are in the product form, or in the quotient form, or in the exponent form, and for that case we use this format of calculation of percentage error, right? Now next numerical is from your current electricity. It says that three copper wires have length and cross sectional area as LA, 2L and A by 2 and L by 2 and 2A. Resistance is minimum in, right? Now see, both all the three wires are made up of copper, means resistivity is same. Here what we have to use is the formula which we have studied, that resistance of a wire is given by rho L by A. Rho L by A. So if rho is constant, then resistance will be proportional to the ratio of L by A, right? So if we find the ratio, we'll come to know the resistance with the lowest ratio of L by A will have the minimum resistance. So let R1 will be equals to LA, right? So R2 will be equals to your 2L upon A by 2, which is equals to 4 times of LA, right? Then we can say that R3 is equals to your L by 2 into 2A, which is equals to, we can write it as 1 by 4 times of L by A. Yes, yes, only these three, na? L by A 2 L by A by 2 and L by 2 and A by 2, right? So here it is L by A, R2 is twice of R1 and R3 is 1/4 of R1. So the minimum resistance will be in the third wire. So let's see what options we have. Wire of cross section A by 2, wire of cross sectional area A, wire of cross sectional area 2A. Same in all the three cases. No. So the correct answer here will be option 3. Option 3, that is the wire having a cross sectional area as 2A has the minimum resistance here. They have asked us the minimum resistance. So the formula which we have used over here is that R is equals to rho L by A, where rho is the resistivity of the material of the wire, L is the length of the wire, and A is the area of cross section of the wire, right? So using this formula, this numerical could be done. Now let's move to the next numerical. It says a charged particle having drift velocity of 7.5 into 10 to the power of minus 4 meter per second in an electric field of 3 into 10 to the power of minus 10 volt per meter have a mobility in meter square volt inverse second inverse of. So see, mobility of electron is simply given by drift velocity upon your electric field intensity, right? So according to this formula, if we simply put the values, mobility of electron will be equals to 7.5 into 10 to the power of minus 4 upon no, sorry, it's a drift velocity. First, drift velocity, right? Drift velocity is, yes, sorry, drift velocity is this, right now. So mobility of free electrons mu will be equals to 7.5 into 10 to the power of minus 4 is the drift velocity upon electric field intensity is 3 into 10 to the power of minus 10. So this will give you 2.5 and this will give you this. So it is 2.5 into 10 to the power of 6. 2.5 into 10 to the power of 6 is the first option itself. That is 2.5 into 10 to the power of 6 is the correct answer. That is the mobility of the free electron over here is 2.5 into 10 to the power of 6, right? See, we have here is the relation is I is equals to NEA VD. This is the formula which is very important out of this topic. So I have written over here I is equals to NEA VD, where I is the current, N is the free electron density, E is the charge on the electron, A is the area of cross section, VD is the drift velocity, right? So this is a very important formula out of this topic, that is I is equals to NEA VD. A lot of questions come from this also, right? Now let's move to next numerical. Let's see what it is. The next numerical is from your combination of resistances. So the equivalent resistance between A and B for the mesh shown in the figure. So here in the figure we have, if we redraw it, we have first resistance like this, then this, then we have this, then this, and this, right? This is your 4 ohm, this is your 4 ohm, this is 8 ohm, this is 6 ohm, and this is 8 ohm, right? So because these two resistances are in series, they will simply add up, so it will be equals to 12 ohm, right? Now what we have now this is, we are done with this. So now we have a 12 ohm resistance in parallel to 6 ohm. So 12 and 6 are in parallel. So using the formula, R equivalent is equals to R1 into R2 upon R1 plus R2. So we'll get R equivalent over here for 6 and 12 is 12 into 6 upon 12 plus 6, right? So it will be equals to 12 into 6 upon 18, and 6 ones are, 6 threes are, and this is equals to 4. So here we get R equivalent is equals to 4 for this. So this results in 4 ohm. So now finally what we are left with is, we have one 4 ohm resistance, then this is the combined resistance 4, and then this is 8. So we have this 4, 4 and 4. Sorry, 8. 4, 4 and 8. So this would result in 4 plus 4 plus 8 is equals to 16 ohm. So the equivalent resistance for this mesh given in the diagram, we have 16 ohm. So the correct answer will be option 3, that is 16 ohm. For the given mesh, we have your equivalent resistance between A and B, because this is the point A and this is the point B, right? So again, this formula is one important formula, that if you have only two resistances in parallel, then directly from R1 into R2 upon R1 plus R2 will give you the R equivalent, right? Now let's move to the next numerical. Next numerical is of Kirchhoff's loop, right? For the circuit given below, the Kirchhoff loop rule for the loop BCDEB is being given by the equation. Okay, so for we do not have to calculate anything, we only have to write the equation for a given loop, and that loop is from B, C, D, E and B, right? So if we move in the direction of current, if I start moving from here, let's start from B, then I2 is moving in this direction, so I would write minus I2 into R2. Then from moving forward, we are landing to the negative plate, so it will be equals to minus E2. Then further moving, we land on the positive plate, so we will write it as plus E3, plus E3. Then again moving in the direction like this, so we will write it as how much will be plus I plus I3 into R1, right? Plus I3 into R1 is equals to 0. So if I take minus as common, it will become I2 into R2 plus E2 plus, no, sorry, wait a minute. This will be equals to I2 into R2 plus E2 minus E3 minus I3 into R1 is equals to 0. And this is I2 into R2 plus E2 minus E3 minus I3 into R1. Right. So the correct answer is 3. Now what the concept which we have used in herein, what convention we take is, then when we move in the direction of current, and suppose there is a resistance, right? We are moving in the direction of current. So the terminal from which the current enters is taken as positive, and the terminal from which the current exits from the resistance, we take it as negative, because while passing through the resistance, the potential drops. So we take it as negative, right? So whenever we are crossing any element in the circuit and we are landing on a negative end, then we write the potential drop across that as negative. And whenever we are crossing any element and we are landing on a positive end, then we write it as positive. So if you see this circuit diagram again, see what I have written here is, for writing the loop, see, when we move from here, we see that I2 is moving in this direction, I2 is moving in this direction. So for R2, this will be taken as plus and this will be taken as minus. So when we cross R2, we are landing on a negative end. So we will write it as minus I2 into R2, because I into R is the potential. So minus I2 into R2. So I wrote minus I2 into R2. Then the next element we are crossing is the battery E2. So crossing E2, we land on its negative plate. So, or because we land on its negative plate, so we will write minus E2. So I wrote it as minus E2. Then what we are crossing? We are crossing the next battery, that is E3, and while crossing it, we are landing on the positive plate, right? So I write it as plus E3. I write it as plus E3, right? Plus E3. Then when we cross R1, what we find that the direction of current I3 is in this direction. So if I3 is entering from here, we write it as plus and we'll write this as minus. So we are moving in this direction. We are landing on the positive terminal of R1. So I will write it as plus I3 into R1. So I wrote plus I3 into R1, and because the loop ends over here, so this will be equals to 0. Why 0? Because what Kirchhoff's loop rule says that the potential drop, algebraic sum of all the potential drop across all the elements in a closed loop is equals to 0. The algebraic sum of all the potential drop is equals to 0 in a closed loop. So these are the potential drop across each elements, 1, 2, 3, 4 elements. There are 4 elements, 1, 2, 3 and 4 elements in this loop. So all the potential drops, the sum of algebraic sum of all the potential drops is equals to 0. Now taking minus common, I'll get this equation, and this equation is in option 3, right? So this is how we had a revision of Kirchhoff's loop law. If you remember this, it will be very easy to write any of the equations for the Kirchhoff's law, right? What? That whenever current enters into a resistance, the terminal from where the current is entering, mark it as plus, and from where it exits, mark it as minus. Now when we are moving in a particular direction in a loop, whenever you are crossing any element, if you land on the negative plate, write the potential drop across it with a negative sign, and if you land on a positive plate or a positive terminal, write the potential drop across it in with a positive sign, and the algebraic sum should be equals to 0, right? So this is what is Kirchhoff's Kirchhoff's loop rule. Now we had seen all the numericals till now. Last numerical is the resistance wire connected in the left gap of a meter bridge. Okay, it's related to your meter bridge. Balance a 10 ohm resistance in a right gap at a point which divides the bridge wire in the ratio 3:2. If the length of the resistance wire is 1.5 meter, then the length of 1 ohm of the resistance wire is. So what they are saying is that there is a meter bridge. There is a meter bridge. Right. Here the resistance wire has been connected, and here we have a known resistance of 10 ohm. Let it be R, and the jockey is placed at the point where it divides it in the ratio 3:2. It means L upon 100 minus L is being given to us as 3/2. So for meter bridge, we can write it as R upon 10 is equals to 3/2. So 215. So R is equals to 50. R is equals to 15 ohm, right? 15 ohm. So the unknown resistance is 15 ohm, and this unknown resistance, they say it is for length 1.5 meter. So if 1.5 meter, 115 ohm is for 1.5 meter, then 1 ohm will be for 1.5 upon 15, which is equals to 0.1 meter. 0.1, as for options, we will write it as 1 into 10 to the power of minus 1 meter, right? So the correct answer will be equals to your option 1, that is 1.0 into 10 to the power of minus 1 meter. So what we have used over here is the equation of balance condition for a Wheatstone bridge or for a meter bridge, that is P by Q is equals to R by S. For a meter bridge, R upon S is equals to L upon 100 minus L. What's the formula? We take it as R by S is equals to L upon 100 minus L. Why 100 minus L? Because if this length is L and the whole length is 100, so this length will be this length will be 100 minus L, right? That ratio has been given to us 3/2. So if this ratio is 3/2, then R upon 10 should also be equals to 3/2. So from there we get that unknown resistance is of 15 ohm. Now for a 15 ohm, the length required is 1.5 meter. Then for 1 ohm, the length required will be equals to 0.1 meter. That is 1 into 10 to the power of minus 1 meter, right? So this is from a meter bridge. Potentiometer, right now it's not in your syllabus, so I have not included the numerical for that. So this was all for the revision. It was a short revision for you all. I hope you all understood the things, and if you have any doubt or if you want any particular topic or a question to be discussed in the video, please drop your comment in the comment box. I would look into it and then I'll make a video for that particular topic for your revisions, because we have a good time for this. 2 week time we have, or out of which 3 days are being gone now. But what we'll do is we'll have some revisions, and if you put some comment in the comment box, I will make videos for those topics also, right? I hope you all understood the things. Please keep on doing the practices and do very well in your BPT 9 and try to score well, right? Have a nice day. Thank you.